Every day we make decisions, presented with choices to pick one thing or the other. As far as we are concerned, the effect of these choices is limited to us. But what if every choice you ever made didn't just change your life, but the whole of our universe, or even the multiverse? When we think of multiverse, certain movies and books come to mind, stories that we adore in the science fiction genre. The idea has been long a topic of interest in science as well. It may have gained popularity in recent times, but the idea has been around since 300 BC. This isn't just science fiction. Some of the greatest scientific theories, from quantum mechanics to cosmic inflation, suggest that our reality might be just one page in an infinite book of parallel universes. Our universe's size in radius from Earth is about 46 billion light years. This is the furthest we can see and is the distance light has traveled since the Big Bang, which happened 13.8 billion years ago. This sphere of our universe is known as the observable universe. It has been expanding in all directions since its inception. Not only that, but is also accelerating. Beyond this distance, we cannot see anything, as light cannot catch up with the rate of the universe's expansion. With time, the observable universe's size will continue to increase, and after a certain point, objects once visible to us, like nearby galaxies and stars, would become invisible as the expansion increases the literal space between us and these cosmological objects. Imagine a balloon with dots on it. As the balloon expands, the distance between these dots also increases. The dots aren't moving themselves, but their surface is expanding. This is exactly what's happening to the space in between. According to the standard model, an energy density inherent to space itself is causing this accelerated expansion. This energy is known as the cosmological constant and is closely associated with the dark energy of the universe. Scientists found that the density of this dark energy was enormous during the initial expansion of our universe, which led to the rapid expansion of our universe during its inception and is now known as inflation. This in turn has led to the idea of a multiverse. The theory states that before the universe started its expansion, the energy density of space, the dark energy, was over 1,000 times greater than what it is today. It caused space to expand rapidly and perhaps at different speeds in different directions. This expansion lasted for about a fraction of a second. As far as we can see, the universe appears flat with no end. If the universe is flat and goes on forever to infinity, then our universe may consist of large parts of space that are so far outside our observable universe that they might behave like their own universes. Some physicists believe in a flat version of a multiverse, that if the universe is expanding and going on forever, there are only so many ways that the building blocks of matter can arrange themselves in a particular arrangement. Imagine a plane that is flat and extends to infinity. Now imagine a finite number of Lego blocks, let's say 5 different colored Lego blocks. You can build many different combinations of these blocks, but after a certain point, the combinations would start to repeat themselves. This is what the theory of eternal inflation predicts. Any finite number of particles must repeat themselves in a particular arrangement in infinite space. The structure of the universe, our galaxy, solar system, Earth, and even perhaps yourself would start to repeat, pointing to the possibility of a multiverse. Eternal inflation predicts that 10 to the 29th centimeter away, there will exist a planet indistinguishable from Earth with beings indistinguishable from us. The theory predicts that the universe is constantly reproducing new universes. Similar to this, there are other theories of inflation with slight variations. Though unlike the theory of inflation, some other theories of the multiverse come from a much smaller level, the quantum level. Hugh Everett in 1957 provided a solution to quantum mechanics problems. His unique solution introduced a concept of many worlds, which is now known as the many worlds interpretation. Everett specifically provided a theoretical solution to the problems of measurement in quantum mechanics, which suggests that at a quantum level, every single thing down to an electron is always in a state of superposition. That is, if an electron is spinning, you cannot exactly know the direction of its spin, left or right, until you observe it. And when you observe it, there is an equal probability of the spin revealing itself to be moving one way or the other. In quantum mechanics, it is said that the object is in a superposition. It is believed to be spinning in both ways until observed. One of the most common answers to this problem is the Copenhagen interpretation, which simply states that the act of measurement or observation causes the object or the system in superposition to suddenly collapse into one state. What made many worlds' interpretation appealing to some physicists is the lack of need for an observer. Under the Copenhagen interpretation, a system is in a superposition state until it is observed, which is a contentious point in the eyes of some. How does the system know when it is observed and when to collapse? While it answers one question, it opens the door to many others. The many worlds interpretation says that instead of a system collapsing into one state, the whole universe, upon every quantum level measurement or interaction, splits itself into multiple branches. That means upon the observation of the electron's spin, the universe will split into two branches from that point. One that now has the electron spinning to right and the other that has the electron spinning to the left. While this happens, the observer in one universe is ignorant to the existence of the other. The person cannot see the other universes, and the connection between these two parallel universes stops existing. In this view, all possible alternate histories and futures are considered real, existing in separate branches of reality. Every decision you make causes the reality to split into multiple possible realities, the very definition of parallel universes. Many physicists back this theory as an answer to questions presented by quantum mechanics. This is not it though. There are many other theories of the multiverse, like the theory of baby universes, which suggests that like our own universe, there exist many other smaller universes within a large universe. The theory calls upon black holes as being the gateway to other universes, suggesting that the interior of a black hole contains a gateway to a whole new universe, just like our universe, which may also be interior of a larger black hole. Lastly, one of the most popular theories of the multiverse in recent time is Tagmarks' 4-level of multiverse. Max Tagmark in 2003 proposed that instead of just one, there may exist a multitude of universes. He organized them into 4 levels with increasing complexity. The level 1 multiverse includes regions of space beyond our observable universe, regions where light hasn't reached us yet. It has the same physical laws as our universe with slightly different initial conditions. This is similar to the theory of eternal inflation. The level 2 multiverse includes bubbles of separate universes in space that formed during a chaotic inflation period just after the Big Bang. Essentially, different pockets of universes formed after the initial expansion of the universe in different regions. It suggests that there are universes with fundamentally different physical laws and constants, maybe even completely different particle types and dimensions. The level 3 multiverse takes the idea of the many worlds interpretation, where there exist multiple branches of parallel universes or realities. Its physical laws are the same as the level 2 multiverse, but at every quantum interaction, the universe splits. In this level, many copies of you exist with different life stories. The level 4 multiverse is a reality where universes exist with fundamentally different equations of physics. It proposes that every possible mathematical structure that can possibly exist for the making of a universe exists physically in the form of universes. As long as math can describe it, the universe exists. A lot of these questions overlap with the philosophy of science. Questions like, was the universe designed or was it a coincidence? Could there really be multiple universes out there and we just happen to be in one that sustained life? The backers of the multiverse theories take support from these profound questions. The discovery of cosmic inflation really does push the idea of space beyond our observable universe. Somewhere very far away, there might be regions of space cut off from our own, equally real. The critics, on the other hand, argue that there is a lack of empirical evidence for these theories. They question, do we really need a multiverse theory to solve complex problems of physics and cosmology, or should we look for simpler explanations? Can a complex universe be answered with simple explanations? Then there's the notion of alternative versions of ourselves in parallel universes, which raises the questions about consciousness and identity. What do you think? Could there be a different version of you watching a different video right now? Let us know in the comments and click here if you want to watch more interesting videos like this.